Hey, what's going on, guys? In this video we are going to see an example on Thevenin's theorem, and here what we are trying to find is we are trying to find the current across this load resistance. And in Thevenin's theorem what we do is we try to simplify this circuit into a Thevenin's circuit. So first of all, this should be a linear circuit. To have a linear circuit we have to have a voltage source, current source and load resistance. And to simplify this one into Thevenin circuit, we have to find R Thevenin and V Thevenin. To find R Thevenin, what we do is we remove the load resistance and then we remove the current sources and short the voltage sources, and we draw our new diagram. Now let's go ahead and draw that one and see how it's going to look like. So we short our voltage source, so that's going to look like a straight line, right? And the resistance are going to remain the same. So here we have 4 ohm and 12 ohm. This is 4 ohm, and then we remove the current source. So when we remove, that's going to look like this. Okay, and then we have this 1 ohm resistance, 1 ohm, and also we remove the load resistance. So at the end, this is going to look like this. And that's it. Now we have sorted this one. Now let's try to simplify this one. And here we have 12 and 4 in parallel. So when we have resistance in parallel, we can find the equivalent resistance by just multiplying them and dividing by the addition. So 12 plus 4, and that's going to give us 48 divided by 16, and that's going to give us 3. So the equivalent resistance for this one is going to be 3. So we can just put 3 right here. Okay, wait a minute. Okay, so this is 3 ohm, and then also we have 1 ohm resistance in series, 1 ohm. And when we remove this current, it means there's nothing right here, so we don't have to even worry about this thing. So we just can draw like this. Okay, and now what we can do is these two are in series, so we can combine them together, and that's going to be just 4 ohm resistance. 4 ohm resistance, and that's it. Now this is our R Thevenin. Now we found out our R Thevenin. Now to find the V Thevenin, we have to remove the load resistance, and also we are trying to find the V across the open. So when we remove the load resistance, this is going to be open, and we are going to find the V Thevenin right there. So let's draw the circuit for this one. So only we are removing the load resistance, others are going to remain. So this is going to be voltage source to 32 voltage, and 4 ohm resistance right here, and we have 12 ohm resistance right here, and then here we have 2 ampere current source, and we have 1 ohm resistance right here, and we are removing this load resistance, so this is going to be just like this. Okay, and if you notice, there's no current flowing through this 1 ohm. So this means when we remove, there's nothing, no current. So it means this node, like this voltage is going to be same as this one. So we can put, this is our VThevenin, right? So if this is VThevenin, this is also VThevenin, because there's no current between this. So this is equal to this one. So we can put the VThevenin right here. This is our VThevenin. Now to find this one, what we can do is we can use any method that's easy for you. Here we can use nodal analysis method, and from this one you can see that current is going through this one. Let's call this one I1, and this 2 ampere is going to go through this one I2, and this must exit, so this one I3. So from now we are going to apply Kirchhoff's current law. That's going to be I1, so the node entering this I1 and I2 entering this node, I3 is exiting, so I1 plus I2 should be equal to I3, right? And let's write this one in terms of voltage. So first I1 is going to be 32 minus Thevenin divided by the resistance across that one. That's going to be 4. So 32 minus Thevenin divided by 4 plus I2 is just 2 ampere, so we can just put 2 right here, and then equal to I3 we have Thevenin, and this is 0, so Thevenin minus 0 over 12, so that's going to be Thevenin over 12. Now to get rid of this denominator we can just multiply this one by 12, so this is going to be just 96 minus 3 Thevenin. Okay, so 3 Thevenin and 12 times 2, that's going to be 24, and here we are going to have Thevenin. Now if we bring this this Thevenin to this side, that's going to be 4 Thevenin is equal to 120. 4 Thevenin is equal to 24 plus 96, that's going to be 120. Therefore Thevenin is going to be equal to 120 over 4, that's going to be 30 voltage. Okay, now we found out our Thevenin, and our R Thevenin is right here. This is our R Thevenin. Now we can go ahead and draw our Thevenin circuit. So let's draw the circuit right here. I use a different color. Okay, let's use this one. Okay, or red. Let's get rid of this one. Okay, now Thevenin circuit is going to look like this. Here we have R Thevenin, that is 4 ohm. R Thevenin is equal to 4 ohm, and we found out the Thevenin, that is 30 voltage. So we have voltage, that is 30 voltage. This is Thevenin, and also we are going to have the load resistance. Okay, load resistance is going to remain here, that is load resistance. Okay, I didn't give a value for load resistance. Let's say this is 5, because we need this one in order to solve this problem. Let's say this is 5, right? 5 ohm. Okay, so here we are going to have load resistance. R load is equal to 5 ohm, and since this is in series, we are trying to find the current across the load resistance, right? Since the circuit in series right now, the current across everywhere is going to be same. So if I find the total resistance, and we know that I is equal to V over R, right? So V is going to be 30, and the R total, so R total is going to be 4 plus this 5, that's going to be 9, right? So 30 divided by 9, and that's going to give us 3.33 ampere, and that's going to be the current across this load resistance. And that's how we do these kind of problems. I hope this helps. Thanks for watching.